In this video, I'll be explaining what is the definition of a radian, right? So in maths, we have different units to measure different quantities. So we know for angular measure, which is circular measure, right? So for circular measure, we know we measure the circular distance from one fixed point to another in degrees, right? So this here, we might say that let's say this is about 100 degrees, right? So if we say this is 100 degrees, that's fine, right? Now, what we want to do, we want to get another unit which describes this, um, which describes the circular distance between 2 points, right? So let's say that we have a shape here, we have a circle, right? This is the center of the circle here, right? Now, let's insert a line here. Now we know that this line here is called a radius from the center to the circumference of the circle. It's called one radius. And let's put another line about here. Right? So this here is one radius, this here is another radius. Right? So suppose that we want to look at this distance outside here, bounded by two radii and the distance on the outside of the curve. This distance here is what you call an arc, right? So the length of this arc is what you call an arc length, right? So this is an arc and this is a minor arc because it's a smaller arc out of the two arcs made by this radii, right? Made by these radii. Now suppose that this arc here has a length of the radius, right? So the arc could be any length depending on how large the angle is. So let's say if this was 10 and this is 10, let's imagine that this length is also 10 here, right? So the two radii and the arc all carry the same length for this special type of shape. This shape here, this pizza slice looking shape, is what you call a perfect sector. Right, this here is the name we give this is called a perfect sector. Right, so what I want to do here, I want to do a little experiment, right? No matter what, I want to see how many perfect sectors I could get in this circle. So let's suppose that this here is about the same distance, right? Let me draw it a bit more accurately. So let's say that this here is about the same distance, right? So this is one perfect sector. This here is another perfect sector. All three lengths are R. And let's try to get one more perfect sector inside here again. And it will look somewhere around here, right? Now, again, my one is not too accurate, but it's close, right? So, now what the perfect sector have to do with what we are looking at here? The angle made by a perfect sector is defined as 1 radian, right? So let's see how many radians we have here. We have 1 radian. This here is another radian, right? And this here is another radian. Now, we almost to the semicircle, right? We're almost here in one semicircle. Right? Let's make it a little bit larger. So I can write this here, 1 radian. So we have 3 perfect sectors. Now look at this here. We have this little sliver here that remains. So let's draw this. Let's draw this to complete our little sliver of this line here, right? So this is our little sliver here. Now, how much is this little sliver, right? This little sliver here, so this is 1 radian, this one, and this 1 radian. Now, if we work out how many radians this little sliver is here, this little sliver actually works out to be 0.141596 dot dot dot. Now, if we add up, this is 1 radian, 1 radian, and 1 radian. What we get here is in a semicircle, in a semicircle, there are 3.141596 dot 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 radians. Or we know this number. 1 plus 1 is 2 and 1 is 3 plus this here will give us pi radians. And this is what we mean that there are pi radians in a semicircle. So in a semicircle, there are pi radians. So therefore, in a full circle, if there's 1 pi radians in a semicircle, there are 2 pi radians in a full circle. Right? So just to recap, right, what we have is 1 radian, and if you want, you can take a note of this. 1 radian is the angle made by a perfect sector. Right? So a few things to note here now. Note 1. A perfect sector, a perfect sector is a sector whose arc length, whose arc length, that's the portion of the circle here, sorry, I spelled arc length wrong, that's okay, right, is the portion of the circumference whose arc length is r centimeters or r units, however long you decide to, whatever unit you use there. 2, there are actually the angle made by a perfect sector is 1 radian, right? On the radian, actually I'll talk about this afterward, right? R centimeters. And 3, there are 3.1415 dot 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 radians in a semicircle, right? Or 3.1415, we know that this number is pi radians in a semicircle, right? So there are pi radians in a semicircle, and last thing to note is that there are 2 pi radians in a full circle. So these are the key points here to take away from this, right? Excuse the handwriting, I'm still getting used to using this writing tablet. Now, the next thing now is how do we link radians and degrees? So another thing that we have to take note of here now, and if you look at these last 2 points here, if we have pi radians in a semicircle, we also have 180 degrees in a semicircle. So this means that pi radians is equivalent to, right? Some people might say loosely equal to, right? But equivalent to is a good thing as well. Pi radians is equivalent to 180 degrees, right? So this is a very, very, very important relationship, right? That pi radians. So this is like saying, you know how we have um, one, let's see if we can go, 1 centimeter is, or 100 centimeters, sorry. 100 centimeters is equal to 1 meter. So even though they are two different units, they are related to each other. Similarly, these two units are related to each other. They measure the same thing, right? So they measure angular measure. So pi radians is equal to 180 degrees. So this here is showing you the definition of what is 1 radian. So I hope that this clears it up for you all. If anybody wants to ask any questions, feel free to in the comment section below. All right, so take care.